So good morning students. In the last class we studied about how the hybrid orbitals will form. So in that we studied types of hybridization, sp hybridization, sp2 hybridization, sp3 hybridization. What is meant by sp, sp2, sp3? Why they are called so? Because one s orbital overlap one, not overlap, mix up with one p orbital, they form two sp hybrid orbitals. One s orbital mix up with two p orbital, they form three sp3 hybrid orbitals. So one s orbital mix up with three p orbital forms four sp3 hybrid orbitals. So okay, this is how the hybridization takes place initially. What are those sp, sp2, sp3 hybrid orbitals means? Those are the orbitals formed by the mixing of atoms of the only one atom. That must be the central metal atom. Understood? We are considering only the central metal atom. There, they form the molecules because, for example, later I will say, okay, while explaining the structures. So, the atom of the same energy, we are selecting what? Valence shell. In that valence shell, there are almost approximately same energy, slightly difference in energy. Those orbitals mix up with each other to form a different hybrid orbitals. Okay, because s orbital is slightly less energy than p orbital, so that somewhat difference is there. To overcome that difference, s and p together mix up with each other from sp hybrid orbitals, and those are all are in the same energy. And the next one is, we studied sp, sp2, sp3, their structure, their bond angle, everything. Okay, so the next one is the percentage character and the acidic nature. Okay, so students, if sp hybridization is there, what is the percentage of s character and percentage of p character? So in sp hybridization, percentage of s character is 50%. It is also 50% because, so 100 divided by how many orbitals are here? S and P, sp, two orbitals. So that is 50. Next, so sp2 hybridization if you take, so this is 100 divided by 1, 2, 3. That is 33.33. So here S character is 33.33, P character is 2p orbitals are there. For one it is 33.33, for two it is 66.66. And take 66.67. Next, sp3 hybrid orbitals. So this is 100 divided by 1 s orbital, 3 p orbitals means 2, that is 25%. Yes, only one is there, so 25%. P orbitals 3 are there, that is 75%. This is what the percentage of s character and percentage of p character. And remember students, if the percentage of s character is more, then atom is said to be acidic. Means if sp hybridization more acidic than sp2, more acidic than sp3. Okay, so sp greater than sp2, greater than sp3. This is what? Increasing order, sorry, decreasing order of acidic strength. Decreasing order of the acidic strength. Understood? And the next one, the percentage of S character is more, then the atom is said to be acidic. And remember, if S character is more, bond angle is also more. Bond angle is also more. Both are S character because sp hybridization bond angle is 180 degree, sp2 is 120 degree, and it is 109.5 degree. As the S character increases, bond order. Sorry, as size character increases here, 25 to 33, 33 to 50, here the bond order also increases. Remember these 2 points, the very important points for NEET examination, because they'll give some compounds here, like any other double bond compound, single bond compound, triple bond compound. Among those, they told you to choose which one is acidic, which one is less acidic, which one is more acidic. Okay, so remember this. Okay, so students, the next one is the very important thing for 3 marks. Structure of hybridization of atoms. Okay. Hybridization of atoms. So the very important one is CH4, NH3 and H2. The hybridization of these 3 is very important. CH4, NH3 and H2. So we will go one by one. Okay, remember? So listen, I'll write some steps here. Initially, the first step to write the hybridization, considering electronic configuration of central atom. First thing. Second one, comparing number of bonds and unpaired electrons. Comparing number of bonds and unpaired electrons. Third one is excitation if necessary. Excitation if necessary. Fourth one, selection of orbitals for hybridization. Okay, next, writing the structure. Okay, students, so these are the 5 points. Of course, this is not given in the NCERT book and everything. Just remember, this is simply a process step. Okay, so first one, considering the electronic configuration of the central atom, compare the number of bonds and the number of unpaired electrons. Next, excitation of if necessary. Okay, next, selection of orbitals for hybridization. Next, writing the structure. Okay, listen. Here, so what we are going to think, I'll consider the first atom, that is CH4. Okay, so in this is the central metal carbon. So students, write here, carbon atomic number is 6, configuration 1s2, 2s2, 2p3, sorry, 2p2. First thing, considering the electronic configuration of the central atom. Once you got the electronic configuration, write the box diagram. Box diagram in ground state. Box diagram in ground state. So this one is we are not considering. This one we are going to considering because this is a complete shell. This is the valence shell. This is already completed. This is valence, last shell. So we are considering only these. No matter whether it is AB5 means VSCPR theory or molecular orbital theory or this type of theory, VPT and hybridization, we need to consider only the valence electron. Here listen, S orbital means only one because spherical in shape. P orbitals means three, that is Px, Py, Pz. You know that how to write. So in the S orbital, two electrons are there. In the p orbital, two electrons are there. So this is difficult. This is 2s, this is 2p. So now comparing the number of bonds and number of unpaired electrons. So students here, unpaired electrons are 2. Okay, means 2 bonds to be formed. But here the number of bonds required is what? 4. Here the number of electrons, unpaired electrons available is only 2. Here the number of electrons required for bonding is how much? 4. So this is what's comparison between this electron and this bond. This is the very important step that tells you about the exact hybridization of the molecule. So once it is like this, of course these electrons also to be involved in the hybridization. So now what you are going to do is excite this molecule. Means, so here I write box diagram in first excited state. Why I am using first means only first time it is getting excited. So this is box diagram. This one is here. 1, 2. Here 2 electrons. So what is this excitation state? One electron of this s orbital, 2s orbital, jumps to 2p orbital. So one electron of this 2s orbital easily jumps to 2p orbital because so in the energy level diagram if we write, this is k shell, that is 1s, this is l shell, 2s, 2p, l shell. Next, this is 3s, 3p, 3d, 4s. This is M shell like that. Okay, these two are of small energy gap. In between the shells, large energy gap. In between the orbitals, only small energy gap. Listen. Okay, means this s electron can easily jump to p orbital. Okay, this means the energies the orbitals in the same shell has small energy difference. Okay, so easily this electron of this 2s orbital jumps to or excited to the 2p orbital. Okay, now here the number of availability of unpaired electron is 4. 1, 2, 3, 4, and the number of bonds is also 4. Then it is complete. Now we need to find. So this one, after excitation, you just consider these, right? Sp3 because one s orbital, 3p orbital. So sp3 hybridization. Okay. Now these are the 4 orbitals of so sp3 hybrid orbitals. 4 sp3 hybrid. Listen here, I wrote S in the different box, P in the different box, but here I wrote all the orbitals, that is sp3 hybrid orbitals, in the same manner. Why? Because they are having same energy, same shape, everything. So the next is Gauss diagram of CH4 molecule. So we consider the hybrid orbitals 4, 1, 2, 3, 4. So here these are the electrons of carbon. Then electrons of hydrogen is paired up like this. Okay, so this is the bonded sp2 hybrid orbitals. Sorry, sp3 hybridization. Okay, now the structure. Listen, sp3 hybridization means it follows tetrahedral structure. So carbon is here. Okay, the structure of these orbitals are like this. Tetrahedral means, so remember, and simply write. Okay, this is how the structure, tetrahedral structure takes place. So listen, here this is simply replaced by what? Carbon atom. Okay, so I'll simply write this. Okay, carbonium. This is one orbital. One orbital. Second, third, four sp3 hybrid orbitals. Of course, the structures are like this. Okay, but I am simply removing the small portions and I am writing carbonium. Okay, next. So students, the carbon having sp3 hybrid orbitals. Now the bonded atom here is what? Hydrogen having valency 1s1, that is s orbital. Means here hydrogen atoms having a spherical shape are bonded like this. Okay, here the two electrons of hydrogen and carbon is bonded. Now the structure is, if you draw, okay, this is what tetrahedral in structure. So students, you write the points here. The first point is sp3 hybridization. Second point, tetrahedral structure. Okay, our tetrahedral geometry. Next, third one, bond angle 109.5 degree. Bond angle is what? This one, 109.5 degree. Okay, this is all about the structure of CH4 molecule. If you write this much, you will get 3 marks, and very important. And as I wrote there, all the structures CH4, NH3 and H2O, all are important for 3 marks. Are you getting this idea? One is considering the electronic configuration, we consider the box diagram. Next, comparing number of bonds and the unpaired electrons. Here the number of bond electrons are 2. Here 4. So we get excited the molecule. So when we excite the molecule, here the 4 electrons are available. Number of bonds is also 4. Then no need to further excitation. Next, what happens? Here, selection of orbitals for hybridization. So we require 4 orbitals. So we are selecting 4 orbitals here. 1 is 2, 3. Why we require 4 orbitals? Here 4 bonds are there. That's why we require 4 orbitals. So 1, 2, 3, 4 orbitals. Next, this is sp3 hybrid orbitals. And remember, whether this is an electron, whether it is involved in bonding or not, it doesn't matter. The valence shell orbitals always involved in bonding. Means Means these s electron, if it is participate in the hybridization, if they may not participate in the hybridization. Even though they participate or not participate, they are involved in hybridization. When they are not involved in hybridization, these are considered as lone pairs. That I explained later. Okay. Next, box diagram of a CH4 molecule. This is the box diagram. So here, this is the electron of carbon. These are the electron of hydrogen. Then this is the structure. Okay. So the next one is NH3 molecule. Okay, remember. So nitrogen is here. So consider initially, considering the electronic configuration of central atom is the first step. Atomic number is 7. Electronic configuration is 1s2, 2s2, 2p3. 1s2, 2s2, 2p3. Okay, next. Box diagram in ground state. Okay, we are considering only the valence shell here. This one, s orbital. This one, p orbital. So 2 electrons are here, 1 electron is. So students, the second one is comparing the number of bonds and the unpaired electrons. Here the number of unpaired electrons is 3. Here the number of unpaired electrons, so number of bonds is also equal to 3. Then no need of further excitation. Means if the number of unpaired electrons is equal to the number of bond required, then no need for the excitation. Are you getting the words? If unpaired electrons and atoms are same, initially in carbon, unpaired electrons are 2, bonds are 4. That's why we do excitation. Here no need of excitation because already the number of electrons available is equal to the number of bonds. Next, hybridization. So students listen here. As I told you, whether they are involved in bonding or not, even though they are participate in hybridization. These electrons are not involving in what? Hybridization. Means sorry, not involving in bonding. The p orbitals are going to be bonded. These s electrons are not involved in bonding, even though they are present in hybridization. So this is sp3 hybridization. Okay, so you can write the 4 orbitals like this. 1, 2, 3, 4. These are sp3 hybrid orbitals. Remember how to write this? This orbital is like this. These 3 are. And just remember the postulate I told you in the before class, before we go. So what is that? Even the unpaired electron, off-filled electron, and completely filled electron also participate in the hybridization. I have clearly explained that in the postulate. You just go and check. Okay, the half-filled as well as completely filled electrons also involved in hybridization. This is sp3 hybrid orbital. This is s orbital like this, p orbitals are like this. Okay, the next one is cross diagram for NH3 molecule. So students, if I take here, these are the hybrid orbitals. So these are the electrons of nitrogen. Then electron of hydrogen is bonded to these orbitals like this. So these are all Sp3 hybridized orbitals of NH3. Okay, so once we came to know this is an Sp3 hybridization, then what is the second step? Writing the structure. Sp3 hybridization means the structure is what? Tetrahedron. So nitrogen is here. So these are the orbitals in the tetrahedral manner. Okay, so three nitrogens are bonded only. So the three hydrogens, the structure is, as I told you, 1s1 means they are spherical in structure. They are spherical in structure. Here the electrons are bonded. Means this is the electron of hydrogen and nitrogen. Here the lone pair electrons are present. What are those lone pair electrons? These electrons which are not involved in bonding. Of course they present, but they are not involved in bonding. Okay. Now if you just write the structure, it follows tetrahedral only. Okay. Next. This is the structure of ammonium. So students, here the bond angle is, instead of 109.5 degree, it is 107.5 degree. Are you getting? Instead of 109.5 degree, it is 107.5 degree. What is the reason? Because one lone pair is there. You know, in the VSCPR theory, I explained lone pair repulsion is greater than lone pair, greater than bond pair, bond pair. So students, these are bond pairs. Okay, there is less repulsion. But here lone pair is there, these are bond pairs, these two. Then what happens? Here the structure is like this in 109 degree, so they get distorted like this. If they are like this, because of the repulsion, they distorted like this, then the bond angle decreases. Decreases to how much? From 109.5 degree to 107.5 degree. Now write the points here. The hybridization is Sp3 hybridization. Second one, so the structure is tetrahedral. You may write distorted tetrahedral because standard tetrahedral is 107.5 degree. Of course, you write tetrahedral, and the bond angle is 107.5 degree. Okay, so this is all about what? NH3 molecules. So students, there may be a rise of question. Why the bond angle of ammonia is 107.5 degree instead of 109.5 degree? The reason is the presence of one lone pair of electron. Okay, so this is all about the structure of ammonia molecule. So the next one, this is also important for humans. I am telling you, among these three, CH4, NH3 and H2O, any one structure is a must and should. It's 100% question for examination. That will ask. And remember, this is a very important chapter. So that's why not even a single point is, or not even a single small topic is removed from this topic. because it is very, very important. Okay, so the next one is third one, H2O. So in this H2O molecule, the central metal atom is oxygen, atomic number is 8, configuration is 1s2, 2s2, 2p4. Next step is Box diagram. Box diagram in ground state. So as I told you, we are considering only valence electron. This is 2s, this is 2p. This is 2s, this is 2p. Now, in the 2s orbital, 2 electrons. In the 2p orbital, 4 electrons. That is 1, 2, 3. Later pair. Because until all the orbitals are singly filled, pairing up cannot take place. So this is 2s orbital 2 electron, 2p orbital 1, 2, 3, again pair. Now the second step is comparing the number of bonds and the unpaired electrons. Next, here how many unpaired electrons are there? 2. Means unpaired electrons means singly filled electrons. These are paired. One is in the above spin, below spin, means opposite spin. This is opposite spin. This is parallel spin. So these are what? Unpaired electrons. Means they are single. These electrons are in body bonding. So here 2 electrons are available. Here also bond formed is 2. So the number of unpaired electrons is equal to the number of bonds formed. So there is no need for the excitation. Okay, next. So here they mention excitation if necessary. If it necessary, then only we need to excite. Here there is no need of excitation. Then consider here. Next, hybridization. So in this hybridization, as I told you, whether they are involving in bonding or not, we don't bother about that. So, but the orbitals of the valence shell are must and should involved in hybridization. S orbital is also completely filled. One of the p orbital is also completely filled. Means they are paired up, even though they are participating in hybridization. So this is what. These are the four. You simply write here Sp3 hybridization. Now, so here you take the box diagram 1, 2, 3, 4. What are those? Sp3 hybrid orbitals. Once they get hybridized, they are of same energy. S orbital of one type of energy, p orbital is one type of energy, so we are separately writing. But the p orbitals are having equal energy, so we wrote together. Once the hybridization takes place, all the orbitals get same energy. You have sp3. So I wrote it. S orbital. This is p orbital. This is single electron. This is sp3 hybrid orbitals. So the next one is box diagram for H2O molecule. Box diagram for H2O molecule. Then consider here the hybrid orbitals. Okay, so this is the hybrid orbitals of oxygen. Okay, so students took this where the singly filled electrons are there the electrons of hydrogen is bonded. Okay, these are what? Sp3 hybrid orbitals of H2O molecule. Understand? Now, once we came to know it is sp3 hybridized, the next one is what? The structure. So consider oxygen here. No doubt it is sp3 hybridized means 1, 2, 3. The orbitals are in a tetrahedral manner. So in the 2 are bond phase means hydrogen atoms bonded here like this. Okay, it's here. One lone pair here, another lone. So students, why? Because 1 and 2 unpaired electrons here. So I just write it this way. Okay, so if you write the structure here, again, this is what? Tetrahedral. But the bond angle here is 104.5 degree. 104.5 degree. Remember, if I write the molecule like this is oxygen atom. These are atoms in there. This one is towards the observer. This one is away from the observer. This is how. So this is hydrogen. These are lone pair electron. Means all are in what? Different planes. That's what I wrote here. Okay? Don't get confused. The bond pair electrons are in the plane and these two are in a different plane. Means towards the observer, away from the observer. Okay? So students, now what happens here? Why it is 104.5 degree? Because as I wrote you, lone pair repulsion is highly greater. Here is also lone pair is there, here is also lone pair is there. They get repulsed. Then, so the repulsion is, if it is like this, only one lone pair repulsion is there. If it is two lone pair, repulsion is too much. Means the bond angle keep on decreases if the number of lone pair electron increases. Okay. Now, here is the hybridization here is what? Same. Sp3 hybridization. Next. This is tetrahedral structure. Next, bond angle is 104.5 degree. Okay, so students, this is all about the structure of CH4, NH3 and H2O molecule. For all, you need to write these points: configuration, box diagram, hybridization, hybrid orbitals, structure, and the bonds. Okay, so this is all about hybridization. The most often asking question about this, except this structure, is why the bond angle of ammonia and water is 107.5 and 104.5 instead of 107.5. Or we simply compare the bond angles of carbons molecule. I'll write here. Compare the bond angles of CH4, NH3 and H2. First point, carbon undergoes sp3 hybridization with 0 lone pair of electron follows standard tetrahedral structure with bond angle 109.5 degree. Next, second one, nitrogen undergoes or exhibit Sp3 hybridization with one lone pair electron follows distorted tetrahedral structure with bond angle 107.5 degrees. Next, third one, oxygen exhibits Sp3 hybridization with two lone pair of electrons follows distorted tetrahedral structure with bond angle 104.5 degrees. So these are the give reason type questions, very important for 2 marks. Okay, so this is all about today's class, hybridization of CH4, NH3 and H2O. In the tomorrow's class, I will discuss with the some other structures exhibiting hybridization. Okay, thank you.